In this activity, we're going to build a continuity meter. So basically, all of electronics, no matter what you look at, whether it is something very complicated like this hard drive controller, or whether it's something incredibly simple like two pieces of wire coming together. No matter what you see, it's all about the movement of electrons, and specifically the movement of electrons in metal. So for example, these two wires here are made of copper, and copper is a very good conductor of electricity. So when I put the two wires together, I'm creating a connection or a path between the two wires for electrons to flow. And if I break it apart, there's no path. In fact, when you look at home, if you see your light switch or the buttons on your keyboard, etc., they all work in exactly the same way. They all basically just bring together two pieces of wire or two contacts. So what this conductivity meter is going to do is it's going to let us see which materials conduct electricity. And that's really important because if I was to do this, nothing's going to happen because plastic, which is the black stuff on these wires, is not a conductor, it's an insulator. So this continuity meter is going to tell us whether something will conduct electricity. So let's see what we need. For this activity, all you need is one jackboard and two crocodile clips, and that's these guys here. And the reason they're called crocodile clips is because when you open and shut them, they actually look like crocodiles. And later on, we're going to need some other objects like some pieces of wood, spoons and things, but we'll deal with that later on. Right, let's get building. Okay, so the first thing you're going to do is you're going to take one of the crocodile clips and we are going to attach it to pin B1. So that's port B, it's going to go to pin B1 on the jackboard. So that's our first connection. And then our second connection is going to be to ground. So this guy is going to go into the ground pin, which is right here. So it's the green one with the G. And we should now have two crocodile clips connected up. The first one goes into port pin B1, and the second one goes into the ground pin. Okay, and here's a close-up. So this one is showing the brown wire going into port pin B1, and the next one shows the red wire going into the ground pin, which is green, and that's shown by the arrow. And these are all connected to port B, which is actually on the top of your jackboard. Okay, the next thing we need to do is turn on the jackboard. So I've pushed the button and the lights are going to flash. And I've already adopted this guy, so it should start flashing blue. And once we see it flash blue, we're good to go. Now that our jackboard's adopted and turned on, we click on the play icon, and this is going to take us to the command page. We need to enter the commands that will make our continuity meter work. So the first one is BTP, which stands for button press, space B1, because that's the pin that we have the first crocodile clip connected to, space L on space 9. And the L on space 9 is telling the jackboard what to do when that button's pressed. So press that one. Then the next one is BTR, which is the button release. So that's BTR space, again, B1 because we're on port pin B1, and then L off. And what this one does is basically when the person releases the button, all of the user LEDs are turned off. So the commands we have now are, the first one is BTP space B1 space L on space 9, and all that's doing is making it so that when the button is pressed, and I know we're talking about buttons and I'll explain that in a minute, the user LEDs, which are this guy here and the ones inside, will all be turned on and they'll be green. That's what the 9 means. And then when the button is released, they'll all be turned off, and that's the BTR space B1 space L off command. Now the reason I was talking about it being a button is that remember what we said at the beginning, all the button is someone pushing two wires together. So you see I've connected these two crocodile clips and the user light turns on. Then I take them apart and it goes off. So again, as I mentioned earlier, every button is just bringing two wires together. Now this button is special because if I touch the edge of the jackboard, that also turns it on because the jackboard is made of metal. But if I touch the label, it won't turn on. And that's because the label is actually made of plastic, it's not made of metal, so it doesn't conduct. So a continuity meter is going to use these two probes to decide whether something is a conductor or not. Okay, now that we've programmed it with the commands, let's start using it. So let's try some basic things. So here's a piece of copper wire. Let's see if that conducts electricity. Get this crocodile clip around. And yes, it does. See, it's going on. So that's conducting electricity. So copper wire definitely conducts electricity. It goes over here, left-hand side. A piece of wood, will it conduct? No, doesn't conduct. So not a conductor. What about a piece of plastic? So this is a plastic ruler. Nope, that's not going to conduct. So that's not a conductor, it's an insulator. How about a stainless steel spoon? Okay, let's try that. And yes, that conducts. Conductor. Piece of wire, so this is a piece of multi-cable. So yes, that conducts, but this doesn't. See, because that's plastic, and that's copper wire. This is a piece of aluminium metal. See if that conducts. Yes, it does. So that's a conductor over here. This is also a piece of aluminium metal. So let's see if this conducts. No, this doesn't. So why doesn't this conduct? So this is metal, same as this, and yet this one conducts very well. In fact, a lot of the overhead high tension power lines that you see around the community, they are made of aluminium, and yet this is aluminium and it doesn't conduct. And the reason that this one doesn't conduct is that it has been anodized, and that's a process that essentially makes the surface last longer, but it also means that it won't conduct. So this piece of metal goes over onto the pile of insulators. So what that tells you is that just because something's metal doesn't necessarily mean that it will conduct electricity. So what can you do next? Well, the first thing is just go around the house trying out different things to see if they conduct. Make sure that you stay away from anything that has mains electricity or plugs into the wall sockets. They are very dangerous and you do not want to go anywhere near them. And after that, you can change the command. So for example, the LON9 command, try changing the number after the LON and have different colors appear. In the meantime, if you need any more help or if you have any questions, just go to www.jackbord.works.